Okay, I think I started. Okay, so let's see, 10:01. Give 1 more minute for people to join. Okay. So yeah. Okay, well, we'll start at the 10:02. Okay. So right now it's 10:01, and just give a minute. Zhijin and Francisco, have you tried your slide? Just make sure that it works.
Yeah. It should work.
It's our normal meeting. It should work, right? Okay. Let's see. Yeah. So there's still people coming. Okay. So just a couple more seconds. I'll start at 10:02. Okay, so 10:02. So I think we'll get started. So today's what we have is an NVIDIA FLARE webinar, and we have a quarterly webinar. For this one is our third one for the third quarter. And for today, we have two talks. One is from Zhijin, who's our solution architect, going to focus on the FLARE deployment. And we also have another solution architect from NVIDIA on the second part, going to talk about peer-to-peer programming with NVIDIA FLARE. Before I let them start their talks, and I'd like to take a minute or two to kind of introducing our next event, which is coming soon in September, called NVIDIA FLARE Day. Just give me a second. Let me share a screen for you. A second. Let's see. So, okay, so let me maximize the slides. All right, so we had a very successful event last year, 2024. So we like to repeat this for the same events. So what the focus of the NVIDIA FLARE Day, unlike any other federal learning conferences, it's not purely on the academia, research papers on federal learning, but just mainly showcase the industry use, how to use the federal learning in the real world applications. So this event this year, we have essentially 3 days. And the first day, in the first 3 half days, the first one is a workshop. The workshop, which is basically is a FLARE team, going to talk about the major features on the FLARE side. That's from, this is US time, it's California time, essentially, from 8 o'clock to 11 o'clock. It's like with 4 talks. And then the main talk is on 17th for US and European time zone, essentially California morning time. And then followed by the APAC and a week later, which is 24th for California time, but the Asian time, Singapore time, is 25th. So with these events, so I kind of this morning I summarize what all the events are. So the FLARE Day events schedules already published and finalized. So we have a ton of talks from all the industries. So here's a quick summary. So for the APAC time, we have a keynote from Professor Han Yu from the Nanyang's technological universities and on federal learning for foundation models. And then we had for the industry, this is kind of a mix of both the APAC talk and the US and EMEA talk. So we had Fred Hutchinson, their chief data scientist, chief data officer, is going to representing this new alliance called a Cancer AI Alliance, and which includes both Dana-Farber, Fred Hutchinson, Johns Hopkins, and the MKSCC. These are 4 major U.S. cancer centers. They are work together, which is with the support with Deloitte, Solomon, the AI2, which is the I forgot what's the name, formal name, Paul Allen Institute for AI, and also all the major CSPs. So and then similarly, we only have other 2 cancer centers. One from Knight Cancer Institute, which is representing the National cancer institute with several cancer centers together. We also have a Moffitt Cancer Centers with several universities, UCLA, University of Washington. So there's at least three talks on the really cancer-related collaborations. And then we have one unique talk from Taiwan. This is on the national level, the Taiwan Ministry of Health and Welfare. And they have presented sovereign AI solutions for medical AI and the devices, especially something they called external AI validations, kind of a FDA approval type of things. But this platform is connected by the multiple medical centers and using Federated Learning. And this have, I think, 15 hospitals together. And then on the drug discovery side, somebody can admit them because on the drug discovery side, we have at least three talks and two major consortiums. One is Amgen going to talk about the FATE. This is kind of a federal AI therapeutic engineering. So it's a consortium of 4 or 5 major drug companies like IBV, Amgen, AstraZeneca, Johnson & Johnson, and UCB. So they're going to do how to do the Federated Learning predict, chemical properties. Eli Lilly, this is a new one. They just have this Eli Lilly Catalyst 360. I believe they have themselves and also a bunch of startups. I forgot to say 10, 20 startups and come together as a Federated Learning network for drug discoveries. And then Roche is also pharma companies, right? But they also do this many cross-country and cross-hospitals type of studies. But this talk, they're focusing on the industry academia collaborations. NVIDIA Holoscan team is going to talk about medical device. In the medical device, especially like a Holoscan type of medical device for operations, how to do this device federated analytics on devices. So they're going to talk about that. And then we have an India company called Partex, and there's a subsidiary called Innoplexis. They're going to discuss the incentive AI, how the revenues, how do you even sustain your Federated Learning framework, so in terms of revenues and the incentives. And then we also have other lightning talks, one from National Taiwan University talk about the medical imaging segmentations, and the other one that will discuss wearable health. So you can see there's a lot of healthcare devices. We also have a financial services. Swiss Bank is one of the biggest banks in the world, right? So they're going to discuss how they do the Federated Learnings, data collaborations and Federated Learnings. And we'll also have a bunch of talks on the edge AI, and many of them related to transportations. So if some of you, if you attended last year, so you remember, we also on transportation side, we had a self-driving cars in cross-country training. So in this time, so we have a Toyota do the electric cars and how to do the battery range predictions, using FLARE. We have this 100 years old company called Cummins, which is the truck engine, right? And when they say engine, it's really the engine on the truck. How to do this after treatment using Federated Learning. And we have the startup who's doing the Federated Learning training on smart cars, essentially on the electronic self-driving cars. And then we also have the other lightning talks on the agriculture, on Jetson trainings, and others. And then we also have several ISVs, the independent service providers, like these are, somebody can mute is echoing. So the Rhino Health Affairs and focus on drug discoveries, duality technologies. All the Rhino and duality, they are both they focus on both healthcare and financial services. Affairs mostly focus on drug discoveries. And we also have Oasis, and it's another startup and building Federated Learning solutions for patient recruitment. In this case, they do confidential computing with genomics researches. And we also have other government, like for example, national labs. There's 3 national labs that together, Sandia, Livermore, Los Alamos, and these are very, they're very government, have a lot of strict security requirements, and so they're using how to do their collaboration for large language model trainings, through swarm learning. And there's another NVIDIA teams called Earth2. They're going to talk about using FLARE not for Federated Learning training, but for kind of data foundation, like a data mesh in the center. If you think about the infrastructure underneath for data processing, they're using that for Earth-2 digital twins, so projects. And we'll have another lightning talk from this sovereign chain AI. They're going to talk about trustless FL infrastructures. So there's just quite of stuff from all of our industries. So really don't miss this opportunities. So that's the just my few minutes, taking from this. So hopefully you can join the event in a couple of weeks. So with that, I'm going to pass to our today's speakers. The first speaker is Zhijin. And Zhijin is, as I mentioned, is a senior solution architect based in Paris. So Zhijin, take over.
Yeah, share my screen and go to full screen mode. Can you all see my screen?
Yes.
Okay, awesome. Okay, thanks, Jackson, for the introduction. So my name is Zhijin. I'm from the healthcare team at NVIDIA, based in Paris, France, in the Europe region. And let me move it here. I don't know why. Yeah, so today I am going to talk about deploying federated learning with NVIDIA FLARE. Here's the brief overview of the agenda. So today's presentation will be very heavy on the demo side. So I'm actually going to spend the majority of the time on terminals, just showing you some live demos for deploying federated systems using different options for deployment with NVIDIA FLARE. But anyway, I'll give you give you guys a very quick refresher on federated learning with NVIDIA FLARE and introduce the various ways of deployments using NVIDIA FLARE from simulation to real world. Okay, so let's get started. All the presented materials are already freely available. We have, I do want to stress out that if you want to try some of the demos yourself after the session, please go ahead. You will have the materials to do that. If you feel that the demo is a little bit rushed and it was too quick, don't worry about it. You'll be able to do that on your own. We have a 5-part, 12-chapter tutorials, which covers basically every aspect of NVIDIA FLARE. This is on our GitHub repo. And then we also launched 2 free NVIDIA Deep Learning Institute courses. So one is an introductory course, and the other one is a more advanced one. And these courses include video walkthroughs of many stuff. And then within the Deep Learning Institute environment, you'll be able to open Jupyter Notebook Lab with compute resource offered by us, and you'll be able to follow notebooks which are freely available as well. Okay, so a little refresher on federated learning with NVIDIA FLARE. We all know that today we have many challenges in data for developing generalizable and robust AI models. These challenges stem mainly from first regulations, including privacy laws, regulation limits, limiting the data access and movements. Also, the availability of data. Actually, there are more data in the private domain than the public, and distributed data are cross country and real data siloed, and they are pretty much sparsely distributed. And finally, of course, the privacy concern. We need to leverage private data while preserving the data privacy, which is one of the biggest challenge in data for AI today. Just give you an example on the healthcare side. A team of researchers recently did some study in 2019. So they analyzed among more than 500 published AI study in the medical field. Actually, the study revealed a striking result that only 6% of the studies included external validation, and even fewer included multi-centric and multi-institutional data. And again, the key challenges here are how to share data in a privacy-preserving way, facing many regulations, including legal and privacy and technical aspects. So building real-world AI requires a paradigm shift. And here comes federated learning, which is fundamentally different from the classical traditional paradigm where we centralize data to a hub and then we develop our AI models. In federated learning, we move model to data, and this way we enhance the data privacy and security. We improve the model's generalizability and diversity and performance in general. And lastly, it is scalable and we offers efficiency in doing that. So this is sort of a federated learning 101, just to get you started. One of the most classic algorithm in federated learning is called federated averaging. So nowadays, most of the neural networks or AI models are trained using mini-batch stochastic gradient descents. So in a federated average setting, you would have a centralized server which sends copies of a global model to different sites. And then each site will be training the model using their own proprietary data without sharing them with other parties. And then after the local training is done, they would send the weights or updates to the centralized server for a aggregation. And one of the most commonly used or classic way of aggregation is simply doing the weighted average. And this way we kind of formulate the mini-batch stochastic gradient descent in a distributed optimization setting. And in this classic architecture, we're talking about a one server, which is the central entity managing the job lifecycle, assigning computation tasks to clients to perform, and then aggregate the result. And then clients, which are local sites who perform the task assigned by the server. And then finally, the workflow, which is a distributed workflow with a very specific optimization, distributed optimization algorithms and communication strategies. So today there are many applications of federated learning across many industries. We are talking about healthcare, for example, in medical imaging, in cancer classification, detection, drug discovery, for example, large language models for protein design, federated analytics of medical devices that Chester mentioned before, also financial services for fraud detection, for example, autonomous vehicle, HPC, mobile applications, and many more. However, implementing real-world federated application is quite challenging, and there are many aspects in terms of challenges. First one, I believe, is practical. We have to talk about developer productivity. Is the SDK or framework easy to use? We have to offer basic capabilities for experimental tracking, logging, debugging, and also project monitoring. And then the second aspect is performance. There are many open research questions regarding distributed optimization and how to design algorithms facing the data heterogeneity, which is one of the biggest challenges in a distributed environment. So how to quickly let researchers easily deploy these ideas into concrete algorithms is what we have to consider in building a framework, in implementing a real world federated learning project. And then there comes security and privacy. We have to be able to offer ways to do proper authorization. We have to talk about data encryption and filtering. And nowadays we're also talking about computational compute, which offer ways to protect the IP of the model, for example. And then last but not least, production scalability, the high availability mode, and the capability of provisioning in a dynamic way. We have to consider also deployments in a mixture of hardware and software setup environments. And then, of course, concurrent job execution that allows you to scale from a couple of clients to 1,000 or even tens of thousands, hundreds of thousands of devices. So that's why we built NVIDIA FLARE. The reason we do that is to tackle all these practical challenges and research questions, so that you have a framework, so that we can offer a framework that brings federated AI and compute to data, basically to everyone and everywhere. It is a enterprise scale federated learning platform. We offer confidential federated learning with confidential compute. It is extremely modular, customizable, and pluggable in terms of architecture. We provide deployment options from simulation to a production environment. So this is the topic that we're going to cover today. Since LLM is such a trendy and hot topic today, we started to support large file streaming for large models, and we have many support for LLM fine-tuning and training as well. It is built for enterprise security and privacy enforcement with many features in terms of security. We actually have a very complete list of enterprise-grade security features. And lastly, but not least, we really value the developer ecosystem and open research. That's why we made the framework to be Apache 2 license, which is open and commercial friendly. We offer fast integration for data scientists and researchers who want to bring their centralized algorithm to a federated paradigm in just a couple of minutes. We work very hard to provide integration with other popular frameworks such as FLARE. The framework itself is built to be completely domain framework and model agnostic. You can bring your own model, your own framework, your task, or even your own software stack. And of course, an extensive catalog of examples and tutorials. Okay, so here's a brief overview of the features and core components of NVIDIA FLARE. So first one, APIs. We have many programmable APIs for server, client, and job, and as well as for project management and experiment tracking. In terms of workflow and algorithms, we have built-in ones, like commonly used ones today. And of course, you can also bring your own by customizing some of the basic components. In terms of runtime for the deployments, we're basically covering all the scenarios from simulation to production environments. And then security, the powerful filtering mechanism, decentralized security, privacy preserving. We include almost all the technologies you need for security aspects. CLI, which provide easy ways for you to prototype, to deploy, to configure your job, for example. And then, of course, examples, a very extensive tutorial catalog, including more than 70 examples. Some of them are research examples, some of them are industry-related examples. Okay, so I'm going to quickly touch a little bit on the design and architecture of NVIDIA FLARE. I believe some of the components are already covered from my previous webinars, so I'm going to be very high level and quick here. The FLARE's architecture design clearly distinguishes three pillars. So these three pillars are applications. So we're talking about server-side workflow development, and then developing client-side local computation, and then putting everything into a job with a bunch of configurations. And then the system aspects. So we're talking about a runtime system that supports deployment in a simulation environment or in a production environment. A powerful event-based system, and we're handling low-level communications for you. And then finally, the user aspects. So users are human participants of federated projects. They need to manage, monitor the project, and interact with a running FL system or a running job. So previously, during our sessions, I think we have extensively covered the application development aspects. And if not, feel free to reach out to the materials that I shared earlier. We have an extensive coverage of how to develop applications easily using FLARE's APIs. So in a nutshell, FLARE's design leverages this powerful controller executor workflow, where the controller assigns task to the executor, and the executors will execute a task and then submit result for the controller to process. And this creates a loop. And notice that during all the moments of data inbounds and outbounds, it is possible to apply what we call the filters on either the task data or the task result. So this filtering mechanism allows us to implement many data encryption and security features. So To develop a federated application using NVIDIA FLARE's API is actually extremely easy. You can basically convert any centralized code to a federated paradigm in literally 5 minutes. So you just have to follow 3 steps. So step 1, start with the client code. So this is usually your centralized compute code, and use client API to convert it to a federated client code. And then step 2, regarding the server side, you can either reuse our existing work controllers, for example, Federers and others, or you can extend the basic controller workflows and implement your own server-side workflow. And finally, the last step is to configure everything and export it to a federated job so that the job itself can be run on any FLARE running FLARE system. So the webinar today's session will be mostly focusing on the system and the users aspect, which is basically FLARE deployments. And I'm going to quickly show you first the options that we provide, allowing you to deploy a federated system. Some of them are for simulated environment, and some of them are meant for production. So the first one is FL Simulator. We're actually not going to cover this today. This is not really a deployment option per se. It is more about testing your application in a simulated environment. So it is for prototype on a single PC. And there's no provisioning process happening behind the scene. There's no clear distinguish for server clients, and there's definitely no security aspects. And you can easily run this either using API or our CLI commands. So this is more about application debugging and making sure that your application development is actually making sense. And then the second one is the proof of concept or POC mode. So this is different from FL Simulator. It is more of a dry run on a single computer. So the goal is to create a sandbox simulated environment, and there's a distinguish between different roles and participants of a federated project. For example, servers, clients, and administrators. It's just that everything is done on the local PC, so that you can provision a sandbox system, test your deployment before moving to the real world. And it's not meant for production because you cannot fine-tune some of the security aspects with the POC mode. And then for production environments, today we're going to talk about 3 options. So the first one is the standardized provisioning. So that's kind of the core aspect of deployment of NVIDIA FLARE. And there are 2 ways to do provisioning with NVIDIA FLARE. One is using the CLI, command line 2. And then the other one is to use dashboard, FLARE Dashboard, which offers a web-based UI. We're going to show demos on both of these today. And then another option is to do containerized deployment. You can use either Docker or Kubernetes to do that. And lastly, we will talk about cloud deployment. And today we support seamless deployment of dashboard, server, and clients to AWS and Azure with basically one command line argument. And for Google Cloud, GCP, we also have a reference architecture. And yeah, that's basically it about the slides. I'm gonna jump to the demos, I think. But before doing that, I just want to tell you that I'm gonna run many terminals. Maybe you will feel that the demo happens too fast, but don't worry. We will share the slides with you afterwards. And in the slides, I documented all the materials for you to reproduce all these demos. So there are 4 series of demos to run. One is I'll start with the POC mode, and then I'll move to the standardized provision with CLI and with FLARE Dashboard. And then I'll move to containerized deployments. For this, I'll only show the deployment using Docker, but feel free to check out our tutorials on how to do that with Kubernetes. And then finally, I'll close with the cloud deployments, where I'll show you an example of deployment using on the AWS EC2 instances. And yeah, feel free to check out our video walkthrough on how to do that also with Azure. And also you can check out the reference guideline from Google Cloud. Okay, I think slide-wise I'm all set. So let me just bring up the terminals. Okay, let me actually move this here so it's not in the way. Okay, so today I will be showing many terminals. I hope all the demos run smoothly, to be honest. And I will explain. I'll explain like what's happening. Like I have many tabs for each of the terminal session. I will explain what these tabs are if necessary. And the first demo I'm going to show is the POC mode. So as I've mentioned earlier, the POC mode is to basically create a sandbox simulated environment for you to experiment an eternal provision and experiment your application before moving to a real production environment. And the CLI command we're looking at for that is basically NVIDIA FLARE POC. If we do a help on this, you can find that there are many subcommands. The one we're going to start with is NVIDIA FLARE POC prepare. So there are many arguments to tweak, but we're not going to do much today. So as you can see, we can, for example, change the number of clients, but we're going to stick with 2 today to be make things simple. So the exact command I'm going to run is actually this one. So this one actually modifies an environment for the default location for the workspace, which is basically the artifact of running the provision command. So I'm modifying the default workspace creation location so that we create something that like directly under current directory. And then after that, I'm going to just launch NVIDIA FLARE POC prepare. So after running that, you can see it's the console log actually says it's done some provisioning, right? And we provision 2 clients. We actually provision 2 clients plus 1 admin user with the name admin@nvidia.com. And we also provision 1 server. So this is the default setting. Let me actually bring my text editor here, and you can see this folder workspace POC is created. And inside of it, there are many content. So for now, we're not going to look into the content yet, but for the next demo, where I'll show you the real standardized provisioning process, I'll explain all the details about the structure of a provision artifact. So let me go back to the terminal. Okay, so after the preparation is done, we will now move on to start the POC provision. So the command to use is obviously POC start. And I'm going to start first only the server and the clients, and by putting the flag -x, meaning exclude, by excluding the admin user here. Basically, I wanted to start the server and clients first, and then start the admin later, and connect to the FLARE console because this is a nicer way to show you, nicer workflow to show you how things could work. So I'm going to start only the server and clients, and after executing this command, you will see many mangled console outputs. Altogether, basically, we're starting first the server and then the 2 clients one by one. And at some point, you will see that both the clients are successfully registered to the server. All right, I'm going to now move on to my second tab here, where I will basically run the same provision command. But this time, I'm going to start only the admin user. And once I start that, you will notice that we will enter something that's called FLARE console. So FLARE console is the administrator's way to interact with the FL system and with running jobs. So it is a console or shell-like interface allowing a project admin to interact with a running FL system. So by typing the question mark, you can see there are many commands to issue inside the FLARE console. One of the commonly used command is check status, for example, and then followed by server. And this is going to list the status of a server. And as you can see, we have a server running, and there are basically 2 clients that are connected. And one is site 1 and one is site 2. All right, so this kind of confirms that we have a running system already using the POC system. So let's actually submit a job to it, so we can examine a little bit how this works. Let me bring up my text editor. So I actually cloned the NVIDIA FLARE repo here, and inside example, I'm going to use from Hello World this Hello PT example. So Hello PT stands for Hello PyTorch, and let's look at the job.py script. So this is basically a script that allows you to formulate a basic federated average training of a very simple image classifier on the CFAR10 dataset. So it's kind of our Hello World example for PyTorch. And this is using one of our latest recipe API, which is basically wrapping around the federated job API. It's pretty intuitive, and with minimal code, you can actually bring up a federated average workflow quite easily. And by default, the script, if you execute it, it's going to run recipe.execute using the FLARE simulator, so in a simulated environment. But I added this line to export actually the job to my working folder, so that we can have an exported job. And this offers us flexibility to later submit this job to basically any running FLARE systems. Okay, so I'm just going to go ahead and run this code. Let me jump back to my first terminal and go to this Hello PT folder, and I'm going to do Python job.py. And after this finishes, I'm going to bring back my text editor. We're going to see that, yeah, this folder, Hello PT, is basically the exported federated job. So the name of the folder corresponds exactly to what we assigned as the project, as the job's name, right? So again, we are not going to talk about application development. Feel free to refer to materials that I shared earlier and our previous sessions where we covered extensively how to develop applications using APIs. But yeah, in a nutshell, this is a folder that you can share and export to any federated running system using NVIDIA FLARE. All right, so let's submit this job. So to do that, I'm going to return to the FLARE console and use the command submit job, and I'm going to add the absolute path to the job. So the name is hello-pt. And after that, you're going to see many mangled console log outputs from the previous terminal where we did the NV FLARE POC start. It's mangled altogether because we actually internally provisioned one server, 2 clients, so everything is so all the console logs are mixed together. But you can kind of tell that the training is running, meaning that the system is running well. And another way to confirm that is to issue the list jobs command, which is also very handy. It lists all the jobs you have executed and you are executing right now. And you can see that our current job, Hello PT, is just running. It's pending finishing. So there's a random job ID that's assigned to each job when you run it. So this ID will change next time when you submit the same job as well. And after waiting for a while, this thing should finish. Yeah, so the fed average finished. And if we refresh on the list job command, you wait a couple of seconds. Yeah, I think now it's finished. You'll see that the status will become finished and completed. And after a job is completed, you can use another command, which is called download job, followed by the unique ID assigned to the job when you submit it. And this will actually bring the server-side workspace to a customized location, which is here. So I am not going to talk about this location yet. I will go into details about this location in the next demo on regarding the for the standardized provisioning. But let's go to this location to see what's inside of it. So let's do cd this location, and you can see the folder which corresponds to the job ID that we just launched. And if you go inside of it, you can see that this is the server-side workspace, which contains many important files for this federated project. And under, for example, under the app server, you can find the global model, global aggregated model. And also we have a TP event folder. So this Hello PT application actually was programmed to stream client-side TensorBoard metrics to the centralized server. So you can, so if you issue the TensorBoard command like this, you can actually visualize the training metrics like this, right? So of course it doesn't make much sense because this is a very toy example. But imagine in a real world scenario, you're running a complicated training job. You can actually monitor using TensorBoard and other tools such as weights and biases and MLflow in real time your training progress, which is pretty nice. So this showcases FLARE's capability to monitor projects using like popular APIs. All right, so I'm done with the POC mode. So after you're done, you can issue the NV FLARE POC stop command. So this is gonna basically stop everything, including the server and the two clients one by one. And once it's finished, you can use the NV FLARE POC clean command. So this thing actually will just remove the workspace POC folder. So yeah, using POC, you verify that your application works in a distributed environment. Although it's a sandbox, it has a distinguished separation between servers and clients and admins. So you're now sure that your application will work in a truly distributed real-world environment, and you're ready to go to production. All right, so that's POC mode. Let me move now to second demo, which is standardized provision. As I've mentioned earlier, there are two ways basically to perform standardized provision. So one is using CLI tool, and the other one is using FLARE Dashboard with a web UI. So I'm going to demonstrate first the CLI tool, but before that, let me explain a little bit. Well, let me actually go back to the slide. I wanted to explain like what provision is in NVIDIA FLARE. So in FLARE, provision is for real-world deployment. It's actually the process of setting up a federated project with participants for a scalable and extensible and secure real-world deployment. So during the provision process, you start with a YAML configuration project configuration file, and then the FLARE provision system will generate what we call the startup kits. So the provision process establishes the identity of the server, clients, and administrators and other users. By generating startup kits for each participant, we make sure that these kits are SSL encrypted, and we also set up the secure communication channels between these participants. So this is what provision is. So let me go back to the my terminal. Whoops. Click the wrong button. Back to the terminal. Okay, so before running the CLI provision command, I want to maybe explain a little bit my different tabs. I actually have 5 tabs open here. So the first 3 tabs are open on my local laptop. And I have 2 other tabs which are open actually on the remote Ubuntu workstation. So the idea here is during this demo, I want to show you a true distributed provision of a FLARE system, and we're gonna submit the same Hello PT job again to witness a true like federated training happening in real time. So what I'm gonna do is to actually deploy using provision projects, and then we're gonna deploy the server and the site 1, the first client, on my Ubuntu workstation, which is remote. I don't have access to. And then I'm going to run the site 2, so the second client, and the admin user with the FLARE console on my local laptop. All right, so let's go ahead and do it. So the command I'm going to run is basically NV FLARE provision. So without any arguments, this is going to by default generate a project YAML configuration template for you. So let's ignore this HA, which stands for high availability mode here, and just go ahead and select the second option. And after that, let me bring up my text editor. You can see that a project.yaml file is generated. So let's examine a little bit the structure of this project configuration file. So we start with some meta information, for example, the name of the project with a brief description of the project. And then the next section is the participants. So participants, as the name suggests, is the list of all the participants of this federated project. You start with the server, and then you have, in this case, 2 clients. By the way, you're free to add as many clients as you want here. And also notice that FLARE has the capability to allow you to dynamically provision new clients even after the system is up and running. So you don't have to turn off the system afterwards. And then last but not least, one and only project admin for this federated project. Now, the single most important thing to configure here in my use case, in this demo I want to show you, is probably the name of the server. This is super important. The name is usually a fully qualified domain name that can be accessed by both the clients and the admin console PC. So I'm going to put, one possible way to do that is to actually put the host name here. So I'm going to put my servers, my Ubuntu servers host name here, because I'll use my Ubuntu server as the server. And then in order to make sure that the server is reachable by clients and the admin user, we have to make sure that the IP address is correctly mapped in the etc host files. So let me go back to the terminal. I do a cat of my host file, and you can see that I have actually mapped the IP address of my Ubuntu remote server to this host name. So there shouldn't be any issue. This is already correctly configured. All right, so this is the participants, and we need to modify this name for the server, and that's pretty much it we have to do. That's pretty much all that we have to do for the server, for the participants. And then the next session is the builders. So I'm not going to spend much time and details on the builder section, but in a nutshell, builders is basically a list of Python classes. During the provision session, the provision system will actually call these Python classes by the order of definition to create workspace, aka folders, for each of the participants. For example, this is going to generate a workspace for all participants, create some static files, and then create certifications and signature files, right? So the only arguments we have to modify here is this service provider endpoint. Since we've modified the server name, we have to be consistent here. So we have to update this server name here as well. And that's pretty much it for this demo. You'll see later we will add some arguments for Docker deployment. But as of now, for standardized provisioning, these are, so the server name here and the SP endpoint name here are the only 2 arguments we're going to modify. All right, so let me go back to the terminal. I'm going to run the NVIDIA provision command. And this time, I'm going to run it with the project YAML file that I just modified. And I'm going to say that the provision result will be saved under a workspace folder under current directory. So after running this, let me bring back my text editor. You can see that a new folder called workspace is created. Now, let's go inside this to look at the contents of this folder. You will see the name of the project. So a folder with the name of the project, exactly as we have indicated in the project YAML file. You also see this prod_00 folder. This is the byproduct of the provision process that contains all the startup kits for all the participants. This number 00 will increment next time you do a brand new provision after modifying, for example, the configs in the YAML file. So these 4 are folders our startup kits for all the 4 participants that we defined, and their name corresponds exactly to what we have put in the YAML configuration file. For example, this one is for the server, these 2 are for the 2 clients, and this one is for the admin user. Now let's look into the content of these startup kits. Starting with the server, you'll see a local folder. This folder actually contains default configuration files that allows you to enable what we call local site policy management in NVIDIA FLARE. So this basically allows you to configure locally, whether you are a server or a client site. You can configure locally the resource management rules, the privacy rules, the logging configuration, and the authorization configuration. So you're free to modify these default values, whatever you like. And this enables us to configure, for example, the server and client side differently in terms of these aspects. And then startup folder. So this folder contains many important files for tamper-proof, for example, certificates and signatures. Be sure to not modify these files manually, because after doing that, you won't be able to start the participants. And then important shell scripts allowing you to start and stop the participants. So in case of this server, the start.sh script allow you to start the server, and the stop script allow you to stop the server. So that's the server. And then the third folder is the transfer folder. This is actually used to hold the runtime artifact during a job execution. And by default, this is always empty. So that's the server side. Client side is about the same thing. So you have local configurations for the client side where you're free to modify whatever you want. And then you have the startup folder, similar as the server, you have the tamper-proof files, and then shell script to start and stop the client. And then finally, the admin folder, which is pretty much the same thing, local configuration files, startup folder containing tamper-proof files, plus the script. And for the admin user, the script name is fl_admin.sh. So this script actually allows you to connect to the FLARE console using the admin's credential. All right, so you as a project admin, after doing the provision, has the responsibility to securely distribute these startup kits to the corresponding participants. You can pretty much use whatever you want to distribute these kits. For example, you can use SFTP, you can use emails, you can set up file servers for the parties to download themselves. As long as the distribution is secured, you're safe to do that, right? So for this demo, I'm just gonna use SFTP to send the let me just go to the workspace folder. So these are the startup kits. I'm actually just gonna use SCP command to send the server startup kit and site1 startup kits to the to my remote Ubuntu workstation. So let me do that. And after this finishes, we can check on the remote workstation side. You can see that the this is sent successfully sent to the remote workstation. All right. So the provision is done. The startup kits are successfully, securely distributed to the corresponding parties. Now the next thing to do is to start the system. So previously using POC, we have one command to do that, but in a real world setting, you have to do that. But consider that you're in a real world production setting. Each party has their own people responsible for starting the services, like IT and administrators. So you have to start each participants one by one. So let's start with the server. So I'm gonna move to this Ubuntu server, and then I'm going into the server startup kits. And to start the server, I'm just simply gonna execute this start shell script. And after a couple of minutes, a couple of seconds, you'll see that the server is turning to hot, meaning that the server has successfully started. As I've shown you earlier, one way to verify that the server has started earlier is to connect to the FLARE console as the admin user. So let's do that right now. Let me go into the workspace, and then I'm going to the admin's startup folder, and the script I'm going to launch is the fl_admin.sh. It's going to prompt me to enter the credential for the admin user. And after waiting a couple of seconds, yeah, you should be able to successfully connect to the server, to the admin console, which basically means that you're connected to the server. So this basically means that your server is up and running. And of course, you can check the status of the server like we did before. And you can see that this is basically we have a server running, but there's no registered client. So now let's register some clients. Let me go to the site one. Let's go into the site one, startup kits, and then I'm gonna start the site one. And after a couple of seconds, you should see that the site one is successfully registered, to the server. And I'm going to jump back to FLARE console. And if I redo the check status server command, you're going to see that site one has successfully joined the project, basically connected to the server. All right. And site two, as I've said earlier, I'm going to run site two on my local laptop. So I'm just going to go to the site two, go to the startup kits and go to site two, startup, and then launch the start shell script. And similarly, after a couple of seconds, you should see that start client 2 is also successfully connected. Yeah, here. So to confirm that, let's do the check status server again. And you can see that we now have 2 sites. And now we're ready to submit the job. So it's basically the same thing we did for the POC mode, right? We just have to issue the submit job command. And let me grab the absolute path of the job. Okay, I'm going to input the path to the job and submit it. And immediately you're going to see many console outputs, starting with site 1. You can see that the training has already started. So this is all happening on the remote Ubuntu workstation. And then site 2, this is happening on my local laptop. And you can see that the training has also started successfully. And on the server side, you will see like aggregation logs, meaning that we have a running federated job. And you can double confirm that with the list jobs command, which will show, please ignore these jobs that I ran earlier. You can see that this is a job we're looking at that we just submit on the Hello PT. There's a new job ID and is running. You can also get the timestamp here. Right, so everything's going well, right? And I think it's about to finish. Yeah, it's finished. And if we redo the list job command, you can see that the status changed to finished and completed. And similarly, after the job finishes, you can issue the download job command followed by the unique job ID. This is actually going to download the server's workspace, which is located in the remote Ubuntu workstation, right? This is going to download that workspace to the administrators, users transfer folder within the startup kit, right? So I'm going to actually show you this folder in my text editor. So remember, the workspace is where the provision artifact sits, right? And this is the startup kit for the admin user. If you click into it under the transfer folder, you can see this downloaded job artifact, which is basically the server's workspace. And within this workspace folder, you're gonna find these global aggregated model, and also similarly the TensorBoard logs, where you can use TensorBoard to visualize the training progress. All right, so download job really allows you to use one single line command to pull all of the server-side result back to the where the admin user is. All right, so that's it about standardized provision. After everything is done, you can shut down. You can shut down. Yes.
Before you move on to the next one, one of audience asked a question for
Yes.
your demo. So he said, was site one remote or is it local onto the laptop?
Oh, it's remote.
Demo?
Site one is remote. Yeah, you see these two colors. They are purple. So these purple colors means that these are remote workstations. So I'm not like I don't have any physical access to these workstations. So these are yellow ones. These are local. This is basically my laptop. So site one is remote, and site two is local.
Okay, good. I just want to make one comment. So many of the interactions are from the FLARE console. There's a shell interactions command. There's a Python API's equivalent. I don't know if Zhijin going to show that or not later, but there's a Python API. You can run similar things in the notebooks. Okay, go ahead.
Yeah, that's correct. Yeah, thanks, Chester. Yes, I'm not showing the APIs, but yeah, like Chester said, all the things I do today, you can do it with Python programmable APIs. Yeah, so that's also an option. Okay, so to shut down everything, I'm going to shut down the client first. It's going to prompt me to enter the admin's credential again. And you're going to see some console logs from the client side, basically saying goodbye, meaning that it's successfully shut down. And then I'm going to shut down also the server again to confirm with the credential. And now the server is shut down. All right, we have, that's pretty much it for standardized provision using the CLI. Now I'm going to show you how to do the same thing, basically using the FLARE dashboard. So let me move to the correct terminal. Yeah, here. So FLARE dashboard is a web-based UI allowing you to basically giving you an easy and more organized way to organize your project and provision your project. And it also allows the participant to download their own startup kits using the web UI by registering their own accounts. So to start with FLARE dashboard, the command we're going to use is basically FLARE dashboard. I'm going to display the help message here. So there are many things. There are many command line arguments to configure here, but I'm not going to do that today. And the actual command line I'm going to do is actually start. I'm going to specify a Docker image name because I already have a pre-built FLARE Docker on my laptop. So I'm going to use that for dashboard deployment. So after issuing this command, this is going to prompt me to enter the admin's address. So I'm going to use admin@nvidia.com. And then I'm going to enter the organization, which is for now NVIDIA. And waiting a couple of, sorry, user container. Okay, I have a running container. Let me just stop it. Yeah, I have to wait a couple of seconds before stopping the container. Yeah, it's done. And let me, I don't have anything. So let me redo the commands. So the admin@nvidia.com again, NVIDIA. Yeah, so the dashboard is successfully deployed and it listens to port 443 on your local host. So and also notice that when you deploy the dashboard, it generates a random credential for the admin user to you. So do keep note of this random credential because we're going to use it later. So now we can open basically any browser and then navigate to localhost port 443. And this is going to open the dashboard, right? So I'm going to log in with admin user that I just defined, and then using the password that was randomly generated by the dashboard command. And after signing, you will be brought to define your project. So let's just quickly do that. I'm going to name it a sample project. This is a sample project and some short description. Example here. Then fun, and then save it. Once you click Make Project Public, you're going to notice another button. So let me log out here. You're going to notice this new button allowing new users to sign up. We're going to do this later. For now, we haven't finished with the admin configuration yet, so we're going to continue there. So we did the project configuration, and the next thing is to do server configuration. You have to put a DNS name here, so I'm going to just put something random here and save it. Now, it is your responsibility as an administrator to make sure that you have a purchase. For example, you have a purchase DNS, and this is actually reachable from all the clients and the admin user. That's our part of the project. And after doing that, let's go back to the project home, and you will see this freeze project button. Now, once you click this and confirm, this is going to actually provision, run the provision process and do a provision for the admin user and the server. And once you've done that, you cannot go back and modify, for example, the project information and the server DNS name anymore. So be careful with that. For me, I'm all good. So I'm just going to click this freeze button. And after that, you'll see that now you're able to download the server startup kits and the admin startup kits to launch the FLARE console. We can go ahead and do that. I'm just going to download it to the download folder. I noticed that each time it creates a random password, it's a zip password protected. So please do note down the password here. You can also download it as many times as you want, so don't worry too much about it either. And if I move the downloaded zip file to my current folder, unzip it, I give it a name server, input the password, and you're going to see that it's actually, let me show you in the file editor. You're going to see that this zip file and its content is nothing more than a provision server startup kit, the local folder, startup folder, and the transfer folder, right? And it's going to be the same thing for the admin user startup kit as well, but I'm not going to download that. Okay, so let me log out. And I'll show you new user sign up. So I'm going to sign up as a new user and give it a name orgadmin@nvidia.com. And I'm going to assign a very basic password, register, and then organization. I'm going to select NVIDIA. And for the member, I'm going to select orgadmin. Now, orgadmin is a specific type of user who has the access right to bring in new sites, to register new sites to the project. Now, after clicking on save, you'll see this UI for adding sites to the project. We can add 2 sites like we did before. So site 1, notice that you have the capability to also specify the GPU resources. So site 1 is running, let's say on, I'm not going to specify that for now. I'll do it later for the cloud deployment, but let's skip that for now. And then, another site 2. And after done, clicking next, go to dashboard. But this is not finalized yet because we registered a new account and we brought up some sites, but these still need to be approved by the admin user. So let's log out again and then log in using the admin user account. And you'll see immediately that there's a new user, the orgadmin that we just created. Let's go ahead and approve that user. So now the user orgadmin is approved. Let's go ahead and look at the sites. And you will notice that there are 2 new sites pending approval. And let's go ahead and approve these client sites as well. So now everything is done. You can go, all the sites are approved. The orgadmin is also approved. Let me just log out and then re-log in using, again, the orgadmin's account. And you'll see that all the sites, you can confirm that all the sites are approved. And if you go into the downloads folder, you can now actually download all the startup kits for the site that you registered previously. So you as a orgadmin, you have the responsibility to download these startup kits, set up all the client site environments, and then distribute these startup kits to the corresponding environments. So if you click on download, this is actually going to download a startup kit. That's basically the same one as we have seen from the standardized provision using the CLI command before. So I'm going to skip that. Yeah, so that's basically provision using dashboard. So it's not much. I mean, I guess dashboard offers a much intuitive and an easier way, more manageable way for you to, for example, define the project. You have a nice UI, and then as org admin or project admin, you can basically you have more streamlined ways to share and distribute these startup kits. So as yeah, that's a pretty that's a pretty cool alternative to standardized provision using the CLI command. All right, I think that's about everything I wanted to show for dashboard. I'm not going to run the same Hello PT example here for the dashboard. It's going to be more complicated, but I'll run it again during cloud deployment. Okay, so I have 2 more demos. I hope the time is okay. Try to finish within 10 minutes. So I have some time for Francesco. So the next demo I want to show is Docker deployment. So for containerized deployment, you can use Docker or Kubernetes. Kubernetes is a bit more complicated, so I'm going to just show you Docker deployment today. So the first thing you need for Docker deployment is a Docker file, and to actually build the Docker image on all the participant machines, including the server, the clients, and the admins PCs. Right. So I provided a very simple one. This is basically just downloading Python, building NVIDIA FLARE, and installing some basic dependencies for this Hello PT job. Right. So I've actually built this container already. I built this image already locally on my laptop, also on the remote Ubuntu server. So this is the tab. This tab is for the remote Ubuntu server. So if I do Docker images, you're going to see the same Docker images that's already built, right? So after that, I'm all set for Docker deployment. Now, the only thing you have to do before deploying is to actually modify the project YAML file, right? So this is basically the same YAML file, and the only configuration we're going to modify is to add this line in the static file builder, is to specify the Docker image that we're going to use. And after doing that, if you provision the project using this project YAML file, you're going to so there will be a new docker.sh script that's going to be generated for all the participants, server, clients, and admin. So let's go ahead and do this. I'm gonna run in FLARE provision. So basically the same command. I'm going to do a provision using this project YAML file with a Docker line modified. And if I go back to my file editor, you can see that this workspace is created, and then inside we can find all these startup kits like before. And the difference is we have now a new docker.sh file. In this case, for the server, and for both sites, you have the same thing. You also have a docker.sh, and similarly for the admin user, you also have a Docker file. Now the idea for Docker deployment is to, instead of using the start.sh, we're going to use the docker.sh. So right now I'm going to go to the remote workstation, and I'm going to deploy. I've already copied actually the startup kits from the my local laptop to the remote workstation. So I'm just going to go ahead, go to the startup kits of the server, and I am going to launch the Docker sh with a -d, basically meaning that I'll be deploying the Docker container in detached mode. And after this is done, we can follow the logs. And you're going to see this is nothing more than just basically spinning up a container and then run the FLARE server, right? And to make sure that we have to verify that the server side is running correctly in Docker mode, we can, for example, go to the admins, startup kits, and then we can actually issue this Docker file. This will just directly bring us into the Docker container, and then inside of it we can run the FLARE admin command script. And then again, with our credential, yeah, I think there, yeah, I think I use another provision and yeah, and then it doesn't work anymore. Let me actually copy this one to, I'm gonna stop this one first. Yes. Let me stop this one. Okay. Stop. Whoops. A workspace one, and you're gonna do the SCP command again. All right, now, yeah, I should have a brand new, yeah, this is a brand new one. Okay, cool. Let me go to this and then start the server in Docker mode again. All right, and let me go back to my local laptop, and I'm going to run the admin console again. Hopefully this time it's connected successfully. Docker. So once again, I'm inside the container, and I'm gonna do FL main. Yeah. So I'm successfully connected to the FLARE container, to the FLARE console, which is basically connected to the server. So this is basically means that the server side is running successfully in Docker mode. And of course, I can check status again. And for now, I don't have any registered clients, but I'm gonna skip that. Yeah, this is basically just want to quickly show you how you can deploy everything in Docker. So if you compare to standardized provisioning using CLI, there's actually not much of difference. The only difference is the added layer of Docker build, and then you're running everything inside a Docker container. Instead of a Python virtual environment, for example. Yeah, so pretty nice if your deployment environment enforces you to use the Docker, right? Okay, I think that's all I have to demonstrate for Docker. Let me shut down the server first. And I'm gonna start with my last demo. Whoops, yeah. Okay, let me go to my last demo, which is about cloud. So you can basically deploy FLARE Dashboard, server, and clients easily using one single argument for AWS and Azure. Today, I'm going to show you how to do that with AWS. Let me explain a little bit my tabs here. So I have two tabs open. So I actually did some homework earlier, so we don't have to wait until like a couple of minutes until we spin up many like EC2 instances on the AWS side. So I pre-did all these things beforehand. These two are so I have, for example, one SSH session already into the a running EC2 instances that's running the FLARE client. One of the FLARE clients, one of the sites, right? And then I have two local shell sessions. This is to start the FLARE console locally, and also to start the site 2 locally. And then I have a purple terminal, which is opened from the remote Ubuntu workstation. So basically, today I'm going to show you how to first deploy a deploy a FLARE dashboard in the AWS environment running on EC2 instance, and then how to deploy a federated project with one server and 3 clients. So the server will be running on the AWS EC2, and one of the clients will also be running on AWS, while the rest of the 2 clients will be running, one on the remote workstation and another one locally on my laptop. So it's a pretty cool and complicated project, and I'm going to show you how easily you can make that happen, right? Okay, so for let's start with the dashboard. So to deploy a FLARE dashboard on the AWS, you can just simply use FLARE dashboard followed by cloud AWS. So issuing this command, you will spin up an AWS EC2 instance, and then it's going to do the necessary to spin up the to configure the EC2 and to open ports for a FLARE dashboard. I actually already done that, so I'm just going to open my dashboard to show you. Yeah, so this is my dashboard. So if I, yes, and this is hosted on the EC2 instance. You can see its public IP addresses here. And I'm going to log into to it using the admin's credential. I've already configured the project, so we don't have to do it live. I configured the project information already, and then the server I configured the server to be this, and I also made sure that this address is accessible both from my local laptop and from the remote Ubuntu workstation, right? So this is already configured properly. And then I also configured using the another org admin, I also configured 3 sites. So the first site, site 1, is going to run on the AWS EC2 instance. I'm going to show you right next how to deploy a site like easily on EC2, on AWS EC2. And then the second site will be running on my local laptop. So I don't have a GPU on my laptop, so I'm going to say GPU number equals 0. The same for the EC2 instance. I'm running on a very small instance. And then finally, the site 3 is going to run on the Ubuntu workstation where I have 1 GPU. So I'm going to put GPU number equals 1, and I'm going to allow the FLARE process to use 30 gigabytes of the GPU memory. All right, so the project is already all set up. Now let me show you how to deploy. Well, let me actually go ahead and download the server startup kit. So let's do that now. And keep note of the password as well. I'm going to bring the server startup kits from the downloads. Folder here, and I'm going to unzip it. Give it a folder server AWS, right, with the password. And yeah, so to deploy a server on AWS is actually extremely simple. You just have to go into the server startup kit, and then instead of launching only the start.sh, you can just simply add --cloud AWS. And after waiting about 10 minutes, you're going to spin up a dedicated EC2 instance, which will host the server, and all the configurations will be predefined and done for you. Now, this is a convenient command. Of course, you can go launch your own EC2 instances and do some fine-tuned configuration yourself. But this is just to show you how you can easily do cloud deployment of a server using only one item, right? And yeah, it's about the same thing for clients. So if we go to, I think I have a client started. It's here. If we go to clients, and you can basically do the same thing. Do the startup. Launch the start.sh script with --cloud AWS, and this will deploy the client on the AWS using a dedicated EC2 instances. Let me just show you quickly on my AWS dashboard, and you can see that I have 3 EC2 instances deployed: 1 for the dashboard, 1 for the site, and 1 for the server. All right. Now I have the server and 1 client deployed. I'm going to go to the remote workstation and deploy the site 3. And I'm going to do that locally. So I'm just going to simply start the script. And in a similar way, on my local laptop, I'm going to enter the startup folder of the site 2, and then spin it up locally. And let's also connect to the admin. Right. Oops. To fill this one, the credential. You see now I'm successfully connected to the server, which is located in the AWS, right? And I can do a check status server, and you can see I have 3 clients successfully connected. So remember, client 1 runs on AWS, client 2 runs on this on my laptop locally, and then finally client 3 is running on a remote open workstation. Now, the last thing to do before I close today's session, my session, is to actually submit the job. I'm gonna grab the absolute path here. So the name is hello PT Adults. And after that, you can see there are many logs. So on AWS side, you can see that site 1 started running and the training just started. And then site 2 locally, the training also started. And then finally, on the remote Ubuntu workstation, the training also started much faster because I'm using a GPU. And we can also double check that with list jobs. And you can see that this job that I just submitted is running. And after a while, when the job finishes, you can issue the download job command with this random job ID. This is going to actually pull the workspace, which is a server workspace, which is located inside AWS, directly to the admin's transfer folder, which is located on my local laptop. Yeah, that's it. I think that's all the demos I have. And I do have like 2 more slides. Yes, very quickly, these are the resources that's going to be useful, I think. So highly recommend you check out our DLI courses. And we have a 3rd one coming up. And as Chester already mentioned, the next FLARE Day. So feel free to register. And yeah, I'm done for me. Thank you very much.
Thank you, Zhijin. I know we actually run out of time, don't have much time for the second speaker. Since we run out of time, I have to apologize for the people who coming for the second talk. We're going to arrange another time for Francisco to talk. Otherwise, he doesn't deserve just like a 5 minutes of talk for his stuff. So I think I just offline talked to Francisco. He's going to share the slides for you, and then we will set up another webinar just for his pieces, so he got enough time to talk about this. Since we have a few minutes left, and I think I'll open to questions, because I know Zhijin FLARE host goes through so much materials, and actually there's 2 parts that he didn't cover. And one piece is we call a pre-flight check. Essentially, when you set up systems, so how do you know the connections are right? So they have a tools that allow you to detect certain things are not working. And then also the other one is for many data scientists, they prefer using notebooks, using Python rather than using terminals. So that's another piece that he didn't get time to cover. But with that, let's open up to questions. Since we don't have a lot of people, so you can just unmute yourself and asking question directly. Yeah. Oh, somebody just asked a question. What's smallest platform FLARE can run? Example of cell phones. Yes, we can run on cell phones. In fact, on the next release, we FLARE Edge, we have been literally packing up. Probably the QA is testing. Yeah, I know the FLARE has a tutorial on that. So we have working with Meta to enable you to run the PyTorch directly on cell phones, both Android and iPhone. So our SDKs will be released literally by next release, targeting the end of September. So we already finished the packaging work. QA is doing the testing. So there's a set of libraries, and then I know some people mentioned about the FLARE. So FLARE also has a feature to run FLARE code directly without change on FLARE. So if you say, hey, I like their libraries, but I like the FLARE's runtime, so with all the enterprise securities and all the other features, and so you can run FLARE without changes directly on NVFLARE. So any other questions? As I said, since we don't have a lot of people, you can unmute yourself and asking directly, or you prefer you can put on chat as well. What's the relationship between FLARE and the FLARE? So both are two federal learning frameworks. I think from FLARE was designed about 3 years ago, and as a part of the real production. So basically, this is initiated during COVID times. We do federal learning across the globe for 20 hospitals for COVID studies. And so essentially, we design from production from get-go. So it's a lot of times. Oh, sorry, I've been kicked out of the room. So give me a second. That's okay. So let me need to find a different room. So the FLARE has a design for production. So a lot of features initially designed for EMEA FLARE is focused on production. So initially we wasn't pay too much attention in the user interface. On the other hand, FLARE has been community driven from the academia side. So a lot of communities are built up from there. So we have been worked together with a FLARE a year ago. So basically, we worked for about 6 months to try to put the two framework together so we can run. You can choose either way. So.
There's an
I'm
open question
in
in
open
chat.
area. Sorry, I need to find a quiet place. So somebody else can help answer the question for now.
Yeah, sure. Is it clear for the FLARE question? Okay, great. Okay, I think there's another question. This seems like a pretty open question regarding how to sell. Selling, I guess you mean selling the idea of running federated learning in general to medical research centers. Yeah, to be honest, during my previous work, I also find it quite difficult to convince hospitals to participate. There are many practical aspects besides like developing awesome frameworks to actually run these projects. Like, for example, you have to curate your data anyway, right? Because many data from the hospital side, they're not really clean and curated. You have to, even though you're not sharing exactly data, like working with multiple hospitals to mount a large-scale project still needs some administrative stuff like contracts and even some regulations. I guess yeah, it could be tricky. It's use case dependent. But I think communication is the key. You have to have a clear goal on the deliverable. You have to show the idea. Try to convince the participants, hospitals that running a federated project to train a generalizable model actually has a clinical outcome and benefits compared to doing this in a silo data network. And you can go beyond doing things in a centralized way. I think showing that is the key to convince the hospitals participant. And then, yeah, take good care and have a realistic estimate on the practical stuff of mounting these kind of complicated projects is also the key, I think.
You yourself went on you yourself mentioned at the beginning that there was like I thought was a pretty strong argument that if people wound up running their models, only 6%, I guess, or something like that, actually wind up validating them outside their own stuff. How big that seems to me to be a pretty good argument for getting people to want to create something that's practical. And it is the first argument that you yourself brought up. Is that really something that people pay attention to?
I think so. One of the first slide we were talking about who's the speakers for NVIDIA FLARE Day, as one of these speakers is from Taiwan, right? So they're essentially kind of it's under Ministry of Healthcare and Welfare, but I think it's working with the Taiwan FDA equivalent. It's kind of so they're trying to validating whatever the medical models whether it's medical devices or medical AI models, are actually can be evaluated, validated externally. Just say, hey, it works in your hospital doesn't mean it's working for the next hospital, right? So that's kind of the process they're trying to do, and then they do that through a federating platform, which is connecting 4 medical centers, and each medical center has 4 or 5 hospitals. Essentially, I think of 15 hospitals together. So that's kind of a validations people do. So in that part, in Taiwan's cases, they make it a national kind of AI strategy to go through the process.
You also mentioned that there's a European company in the Netherlands that's going on and using federated learning for stuff as well. Is it the case perhaps that national health services care more about this kind of stuff than individual hospitals?
So there's quite a bit of European companies doing this. The one I mentioned is the Netherlands, is Oasis now. So that is they do like a patient recruitment. Like if you do rare disease, you couldn't find if you want to do a study, you couldn't find the matching patient for the projects. Many projects failed because of that. And so there's multiple companies try to find patient recruitment in a sense. And I think this company start from that as a first project, and then I think it expanded from there, going federal learning, genomic studies, computational computing, that sort of things. But there's many other companies using FLARE to do similar type of things. Like Finland has there's the health systems using the similar studies. European has this something called in last year's event. They talk about what is called Zhijin. We're talking to the monthly. Now, top of head is
Optima.
Optima, yeah, Optima. Yeah, Optima Oncology. It's like 37 or 38 European companies across 14 countries. So there's quite a few of those, which I didn't list on the this FLARE Day event because we just got too many. We couldn't fit them all to give talks.
Thank you.
So there's I think the momentum for federal learning adoptions increasing, growing compared to 2 years ago. So this is we are literally working with even though like financial services will only have one bank talk, we actually were working for multiple major banks from big names on the financial side as well. So and then there's many other projects which is not listed on the talk. So there's a growing adoptions, and then FLARE has been not only gradually improving our infrastructure system communications, but also on the user interface part, we make the API really simple, as you can see from the client side, just a few lines of code changes from the job configuration. Instead of you're editing the JSON file we used to do, literally use 6 lines of code using the recipe APIs to generate this automatically for you, and you don't even need it to see it. So make it the whole things are really easy for data scientists, and we're continuing to improve that for researchers as well. So this is pretty exciting actually to see so many applications for different industries cover so much wide areas. Unfortunately, we didn't get time for Francisco to demonstrating his peer-to-peer type of API. So he's doing stuff really cool, the distributed optimization, think about a drone, talk to each other and all that sort of things. And then we also have a talk for federal learning, not for learning at all, not for training at all. There's a company, so last year Deloitte talked about federated RAG. You think about agentic systems using federated agentic systems. And then Deloitte did that, and then they're actually a financial company implement that. And even though we didn't invite them to talk this year, so they are literally pushing for production using FLARE to do that. So there's a lot of exciting stuff working in progress.
One of the things I really liked about the stuff that you've done is that these descriptions of your use cases, which are quite practical. For example, I'm on the medical side, so rare disease patients having the ability to go on and aggregate those into a single study, or some of this, the point you brought up too about validating models in more than one spot. a friendly suggestion, perhaps when you present this the next time, talking about what the benefits are that Federation goes on and provides, it's difficult to achieve any other way. Those are examples of the kind of stuff. So if you're able to, the technical stuff is compelling. I find that useful too, but the use cases are what need to be sold. And as a result, I think, and since you have some, perhaps ferreting out these points that seem to be practical, are providing value now and whatever, putting those on a front slide, you may find out help you a bit when you sell this stuff out.
Yes, yes. So yeah, we're working with, for example, I mentioned in one of the cancer center, 4 cancer centers, Dana-Farber, Fred Hutchinson, that stuff. So they're building a platform. They want to show, not only say, hey, we work with the 4 cancer center, but also show that they go through the legal, the internal board review, privacy, all that stuff. They want to showcase that. And essentially, one of the big hurdles is not really technical. It's the so-called IRB, right? Internal, what is it called? IRB,
internal review board.
Yeah, exactly. Internal review board. So that part, it was difficult to go through. Like if a data science say I want to use data set, well, you need IRB to get approval, and they may not allow you to use it. But by allow them to build out the platform, they essentially go through once, everybody can in the project can participate. That's part of the whole process. And they're trying to show to the world.
And in fact, I wound up working on a non-invasive blood analysis machine. And for a lot of trials that people do, going through the IRB is the first big hurdle. The thing that Federated Learning has to offer is that here you have the ability to go on and aggregate data, for example, from rare patients without revealing their identity and still being able to go on across a large number of multiple institutions. That's a very concrete benefit that when you go on and sell to hospitals or groups of hospitals, I present on the first slide at the beginning. And so you have, and the thing that's cool about it, it sounds like with Fred Hutch, you already have a hospital that's recognized that and is using it, because hospitals are loath to be first, but you already have someone who's been first and they're realizing the benefits. And it helps the most difficult part of putting these things together, which is the IRB. So you've got an IRB Slayer app, okay? And what it does is it goes on and provides protection to all the stuff, for the stuff that they need to go on and protect, and goes on and provides results that they can publish. If you go on and show you can get through the IRB faster, provide protection to the patients, and are able to publish stuff that's new and unique, that is a selling point.
Yes, totally agree there. Yeah, totally. But at the goes through the generic IRB approval, that part is very hard. So we have to continue working on that direction. So anyone else has comments or questions related to the talk? So if not, just say one more words. So we are preparing for the Q4 webinar. And for Q4, we probably going to just invite 2 industrial speakers, either from ISV, one of the ISVs of areas or somebody else, or Roche, to talk from their perspective in terms of what the lessons are learned in their process, either things they developed or the hospitals they develop. So the much because of the FLARE day, we only give them 20 minutes because there's too many talks. So in there, we're gonna give them like here, 1.5 hours, and split it between 2 talks. And so each one has a longer time to explain details. And so that'll be Q4, probably the end of November, early December time. So looking for that as well. Okay, with that, thank you so much for coming and stayed to the end. This is a very long webinar. We'll find time for Francisco to do the the second part of the talk soon. Okay, thank you very much. Bye-bye.
Thank you very much. Have a nice day. Thank you.
Thank you.